Hello, Wallstreetosmium. Yup, that's right. The subject of today's video is osmium tetroxide, the accursed compound that plagues the hearts and minds of anyone who so much as thinks about the word osmium. But more specifically, I'm going to be talking about the oxidation rate of fully dense and sintered osmium at room temperature, and how much osmium tetroxide you can expect to encounter over a lifetime of wearing osmium jewelry. Now, everybody and their dying grandmothers already know that osmium tetroxide is toxic. But how much is considered toxic? So first, I'd like to look at the odor threshold for osmium tetroxide, because it has been said many times by many people that osmium tetroxide becomes toxic at concentrations lower than the threshold at which you can smell it. So right here, the threshold odor in air is the odor threshold in air is 0.0019 parts per million. Now, we don't want to use parts per million for this. What we want is milligrams per cubic meter of air. So in order to do that, we're going to look at this website here, and we're going to pull up a calculator. Actually, we're going to need more than one calculator. We're going to need a few calculators for this. So I'm going to enter number of molecules in 1 meter of air. That's 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay? Now we're going to divide this number by 1 million, because that's the number of, we're working with parts per million. We get that number. And now we are going to multiply this number by the value that was given, which is 0.0019. And that's how many parts per million we are, well, that's not how many parts per million, that's how many particles there are total. But that's the parts per million, that's how many total, okay? So then we need to take 1 mole, which is 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. That is how many particles are in 1 mole of anything. And we are going to divide this number by this big number. Okay, divide by that number, and we get 11,951,258, and then all this shit right here. Now, this is the number that we need to divide osmium tetroxide's molar mass by to get the milligrams per cubic meter of air concentration. So I'm going to pull up yet another calculator. I'm going to enter osmium tetroxide's molar mass in milligrams and divide that by this number. And we get in milligrams 0.021 milligrams per cubic meter of air is the odor threshold, okay? So this is how many milligrams, okay, ignore these other two. This is how many milligrams of osmium tetroxide per cubic meter of air you need in order to smell it, okay? Now this number may or may not be important to the rest of the stuff that we're going to be looking at today. So now we're going to go here. And see this stuff right here? This is the unit that we want, okay? Now bear in mind, This was a real rabbit, okay, that was in a laboratory that somebody picked up, put into a container full of osmium tetroxide, and killed it. Yeah, so just bear that in mind, and we'll gloss over the whole rabbit genocide thing. Because honestly, this amount right here seems a bit overkill. Now, right here, inhalation for a mouse, lowest published lethal concentration, 40 parts per million. Now, I could go back and do all this stuff with the math and everything, but I don't really need to, because I found out later on that all I need to do is take this number, 40 parts per million, multiply it by 10, and you will get the number of milligrams per cubic meter of air, roughly. How I know that? Because I went down here and looked at this, did the calculations myself, and found out that, holy shit, they were right. They already calculated it. So basically, this rat was exposed to 400 milligrams per cubic meter of air for 4 hours. And that's the lowest lethal concentration inhaled by a rat for osmium tetroxide, which honestly sounds like a bit much. If you ask me, that sounds like a lot of osmium tetroxide, especially since people say that it becomes toxic at or below this amount of milligrams per cubic meter of air. Yeah. And this is what it was for a human being. 133 micrograms per cubic meter of air is the lowest published toxic concentration, okay? That's the lowest published toxic concentration. Now this number right here, that's the odor threshold, okay? This lowest published toxic concentration is a lot more than that. Let's actually find out how much more, okay? So we're going to take 0.133 milligrams, which is the same as 133 micrograms, and we're going to divide it by 0.021 milligrams, or 21 micrograms, and that's about 6 1/3 times the odor threshold, okay? Now I'm not doubting that anything less than that, I'm not doubting that the odor threshold is toxic. I'm not doubting that. I'm not doubting that anything below that is toxic. I'm just looking at what's published here, and I don't know how that went down. Okay, I don't know if you had a guy who was exposed to osmium tetroxide, died, and then some guy in a hazmat suit came and put out some rod or something like that, and some magical rod that could take measurements and tell him exactly how much osmium tetroxide there is. I don't know how they got this figure. I mean, that's a pretty exact figure. How did they get that? Okay, so this is a review that was written by Mattel Weimer, and it goes on to say that the oxidation rate for osmium beads and crystals is below 0.001 milligrams per year. Now let's let's just assume, okay, let's assume that the rate is 0.0005 milligrams per year, okay? And let's also assume that I have generously 70 years left to live, because I'm 31 now. Now let's multiply this by 70. I want you to take a look at these two figures here. Okay, this is the odor threshold. This is how much osmium tetroxide I can reasonably expect to accumulate over the course of the remainder of my life, if I live to be that old. It's really not a lot more than the odor threshold, but that's over the course of the rest of my life, okay? That is an extremely tiny amount. But then I wondered, okay, so if this is the lowest published toxic concentration for a human, not necessarily lethal, how much am I being exposed to right now? Well, all we got to do is we got to take our presumed figure, which is 0.0005 milligrams per year, divide this by 365, and oh yeah, we get this number. Hoo hoo hoo. Yeah. And then we divide it again by 24. And we get this number. So that is 0.1234567 That is how many milligrams I've been exposed to within the past hour per meter of air. Okay? I think per meter of air. No, that's how much has been produced around me from my pendant that I wear 24/7 within the past hour alone. Now that is that's below the nanogram range. Oh, that is ridiculously small. What the hell unit of measurement is below nanograms? Anyway, that's alright, now I told you we come back to this figure. 40 parts per million over 4 hours. So that's 400 milligrams per cubic meter of air for 4 hours. So let's take this number, times it by 4, and we get that figure. Take out another calculator. You know, I've already got this one memorized, so let's just get rid of it. So 400 divided by 0. How many is that? 1, 2, 3, 4, 5, 6, 7. Okay. 1, 2, 3, 4, 5, 6, 7. Alright, so that rat over 4 hours was exposed to 1 billion times more osmium tetroxide than I've been exposed to over the past 4 hours. Okay? 1 billion times more. 1 billion! Osmium tetroxide, it's so bad, don't wear osmium. Yeah, these are the numbers we're looking at right now. Now, this human, I don't know how long, what the duration of this was. Let's just assume that it was, like this says, acute toxicity, that this was over a very, very, very short period, an hour or less, okay? So let's get our calculators back out. divide this number by 4 so we can get back to an hour. Now, 0.133 divided by 0.1234567 yeah. In an hour, he was apparently exposed to over 2.5 million times what I've been exposed to in the past hour. That's a lot. That is really, really a lot. And it is also divided by 0.035. It is also almost 4 times the amount that I can expect to be exposed to over the rest of my life, okay? That is a lot. That is seriously a lot. Now, the question becomes, because they say that, the odor threshold is toxic. And I've also read that osmium tetroxide has what they describe as an insidious accumulation effect. But I don't think the odor threshold is lethal, because I've heard of people smelling it before and not dying or anything close to dying. So I think it's safe to say that if it's spread out over the course of the rest of my life, that it's probably not toxic. No. Okay, so if we take a journey back in time, about 2 months ago, to when that person posted that photo of his osmium ingot that had oxidized in the container over 5 years. Now, Mattel Weimer responded by saying that he speculated, based on certain calculations I'm sure, that the oxidation rate was below 0.5 micrograms per day. Ooh, that's kind of a lot compared to fully dense osmium. So, let us start doing some calculations. Let's just assume it was 1 microgram a day. Or, I'm sorry, no. 0.1 micrograms per day. Okay, so 0.0001. So 0.0001 milligrams a day. Let's time this by 365. Ooh, getting close there. Times 5. Oh, look at that. So that's almost 0.2 of a milligram over 5 years. I can see now why that plastic container got so badly stained. Almost 0.2 of a milligrams worth of osmium tetroxide, and it is a very strong staining agent, so there you go. Now let's up the ante a bit. Let's divide this by 5 again, so we have 1 year times 70. So 2.5 milligrams of osmium tetroxide over, well, basically for the rest of my life if I were going to wear it around my neck, for poorly sintered osmium. Now this is going to be a worst case scenario, assuming your sintered osmium is badly sintered or something. So let's just assume that the oxidation rate for well-sintered osmium is twice that of fully dense osmium. So let's say that it is 0.001 milligrams a year. Okay. I'll time this by 70. And we get, over the rest of my life, 70 micrograms of osmium tetroxide. That's definitely, yeah. Yeah, that's a bit more than the odor threshold, isn't it? That's, yeah, that's a slightly more than 3 times the odor threshold.